Okay, who can tell me what makes this a quadratic inequality? It's actually a pretty simple answer. Okay, that makes it an inequality. What makes it quadratic?
Because there's an equation on one side.
Because of the x squared. Yep, it's because of the x squared. If it didn't have an x squared, it wouldn't be quadratic. Okay. It's a cubic function. Okay. First thing you can do, move everything to one side, just like you do when you solve a quadratic equation. Okay. Now, I know I have an equal sign here. I know it's not equal to, but for the sake of solving for x, it's easier just to write an equal sign. Okay. Just don't forget that it does have a less than or equal to. So I guess I can show that. I mean, why not? Okay. Just to be technically correct. So again, let's read this step. Determine the x values in the number line. It's the same steps as just solving for x. So subtract 6. We can see now that once we get everything on one side, we can use the, what's it called? X method. So 1 times negative 6 on top, 1 on bottom. Two numbers that multiply to give you negative 6, 3 and negative 2, add to give you 1, 3 and negative 2. So you can actually use the shortcut here, right? You can write it as x plus 3x minus 2. And when you set each of those equal to 0 and solve, you get x equals 2 and x equals negative 3. Okay? So you will be using a number line, you just won't be graphing the actual answer. Okay? And yesterday we spent some time putting numbers on number lines and shading them, which is what we're going to be doing today. So any questions on this first? It's just using the x method. Okay. So next, okay, we will be graphing x equals 2 and x equals negative 3 on the number line. Will it be a solid point or a hole? It'll be solid. Yep, because it equals. Correct. Every time you have an equal sign, even if it's under, less than, or greater than, with that bar, means you're going to put a solid point. Okay?
What happens to our less than or equal to
What?
What happens to our sign? Like, is that?
It's a solid point because it's equal.
I know, but like at the end, that's like where it's supposed to say less than or equal to.
Like, we'll talk about that. Yep, good question. She's basically asking what happened to this. Well, we will definitely address that. Okay, but for this step, you're just going to place those x values on the number line. And again, if it's this, you would put it solid point because of this bar down here. That's all that's. Okay, and this was in the original question, right? So that will influence our answer as we get through this problem. The real question now is, how do we shade this? Okay. How many sections have we created with these 2 points? 3. Good, 3. We have a bunch of numbers to the left of negative 3. We have some numbers in between negative 3 and 2, and we have some numbers to the right of 2. So you get to pick numbers you want to plug into the inequality, your original inequality. Okay. Remember, here's our original inequality, and this is where this sign comes into play. This is where it becomes important. So we will choose a number to the left of negative 3. To me, the easiest number would be negative 4. We're going to pick a number in between negative 3 and 2. Always go for 0. 0 is very easy to plug into x. And then finally, to me, the easiest number to the right of 2 would be 3. Certainly, you could pick any number you want. And we're going to plug those into the original inequality to see if they work. Okay? I'm going to plug in negative 4 here. Every time there's an x, that's my first test value. I'm going to plug in 0 here. And I'm going to plug in 3 over here. And I have a question mark above the inequality because I don't know whether or not it's going to work out. In other words, I don't know if this is going to be less than or equal to 6. Maybe it will, maybe it won't be. Also here, well, you can kind of tell. This one will be, right? You're going to get 0 is less than or equal to 6. It's going to work. Okay? That means you're going to end up shading this region based on that number you picked.
Why are we doing it?
it's going to give us the answer. Do what? No, we're worried about the numbers in between them. Yep. We're worried about the sections that they create. That gives us a test value. You will never actually plug those numbers in, those actual numbers, okay? You won't need to plug those in. Just numbers around them and in between them. Okay, so step 4, we've plugged the test value, and now we just have to check to see if they work. What do you guys think about the left? You think it's going to work? No, how'd you know that? This is 16, right? Plus -4 is 12. 12 is not less than or equal to 6. Okay? So our first test value is no. It is not a valid statement. The next one we said was going to be 0. 0 is less than or equal to 6, right? So it works. The third one we plugged in, just to remind you, I'll go back. You're going to get 9 plus 3. 9 plus 3 is 12. That is not less than or equal to 6. That one doesn't work either.
Are you always just going to have like one that works?
Nope. Sometimes you'll have 2 that work and 1 that won't.
So what do you do if you have 2 that work?
Then you shade those 2 parts of the number line. Okay? So actually, sometimes none of them will work. Sometimes all 3 will work. All 3 is the easiest because you just shade everything and the answer is all real numbers. Okay?
So if there isn't anything that like none of them work.
None of them work? No solution. Yep.
But you still put the dots, right?
Yes, you do.
Okay.
Okay, so everybody see the middle section worked? That just means that we are going to be shading this part of the number line. Okay? The points between -3 and 2. Okay, so step 6. Shade the regions on the number line for which the test values were valid. Okay? What was step 5? Check the validity of each test value. Okay, so we will shade everything in between because we plugged in 0 and it worked. Now, because they were solid points, that's going to influence our final answer. It's not just everything between -3 and 2, but because of those bars, the way you would read your answer is -3 is less than or equal to x is less than or equal to 2. That's your final step. You're determining the union of shaded regions anywhere on the number line that is shaded. Okay, so it's a combination of everything. In this case, it's just one shaded region. Any questions about this answer being a compound inequality? I know we talked about it yesterday. The number on the left goes here, the number on the right goes here, and then x goes in between them. And you put bars here because they were original bars. Those are solid points. So that means any of these numbers you plug into the original inequality will work. Okay? Questions on that? We could do more examples, but I think I'm just going to give you the worksheet to work on that.